Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the October 2023 Pure Mathematics P3 International A-Level Edexcel this exam here. And we have here a question which is about this strange looking curve. It says, figure 1 shows the sketch of a curve with equation y equals f of x, where f of x is equal to e to the power of negative x squared times 2x squared minus 3 squared. Find the range of f. Okay, so the range of a function is the values that its output can take. Okay, so here there's no restriction on the domain. Okay, looks like it can go on forever, right? So any x value can go in here, but from the look of the graph, we can see that it seems like it's going to start from the x-axis. It won't go below the x-axis, right? And we can see that from this because, both of these will never ever be negative. Okay, so f of x will always be positive because this is going to be squared, right? And this is going to be something also which is e to the power of x or e to the power of minus x. Okay, if the minus is inside the functions, inside this part here, then that will never be negative. So this thing will never be negative. We have positive times positive. So you can see that the range begins from the x-axis. Actually touches the x-axis in these two places. Okay, as we can see. And we can see that the range stops at the point where the curve turns at the top here. Okay, now because that place where it turns, you can see clearly it's on the y-axis where x equals 0. We can find that point by just replacing x equals 0 into this equation. It will tell us the y coordinate of that point. And that will be the limit. So we can see here that that point here, we have to find what it is by putting x equals 0 into this function. When x equals 0, then you end up with e to the power of 0 times 2 times 0 squared minus 3 squared. So that's going to give you 1 times, that's going to give you minus 3 squared, minus 3 all squared, which is going to give you 9. So we know that when x equals 0, y equals 9. So this point here is 9. So the range, therefore, of this function is between 0 up to 9. That's the range. That's all the output values you can get from this function. Whatever value of x you put in will range between 0 and 9. It won't go below 0. It won't go above 9. And 9 is included because it's going to actually hit 9. So we can say that the range of the function f of x is less than or equal to 9 and greater than or equal to 0. So you write it in this form over here. That's how you should write it. Okay, so there's the answer to this question here. If you wrote it in interval notation, that's also fine. You put 0, 9 like this, okay? But it's better to write it in this notation here. So there we have the answer to part A of this question. Pretty straightforward. No need to find these turning points, okay, in part A. It's only worth 2 marks. No, of course, we can see that these turn on the x-axis and this turns on the y-axis. So, we know the y value on the x-axis is 0, and we can find the y coordinate of where something hits the it's the y-axis by replacing x with 0 into the function. So there's part 1, question 7, part A done. Now for 7, part B, it says, show that f dash of x, when you differentiate the function, you get 2x times 2x minus 3 times e to the power of minus x squared times a minus bx squared, where a and b are constants to be found. So we have f of x equals this. This is the original function from the question. So we have a product of 2 separate functions. Okay, so it's not like you have this is the differential of what's inside the function, so we can reverse the chain rule. No, we have to use, so we can use the chain rule. Okay, ignore what I just said. It's nothing to do with anything. All right, that's to do with integration. It's a bit early in the morning. Okay, there's no reversing the chain rule here because we are differentiating, not integrating. So basically, we have the product of 2 separate functions, and what we have to do is we have to differentiate this. So we call one of them u. It can be either one for the product rule. So u equals e to the power of minus x squared, and the other one we're going to call v. That's 2x squared minus 3, and that whole bracket is squared. So when you find u dash, Okay, when you differentiate something like e to the power of something, it just stays as it is. It doesn't change at all. However, if there's a function inside the function like there is here, you have to differentiate that. So if I was to differentiate e to the power of x, I would get e to the power of x. But if I was to differentiate e to the power of kx, I'll get k times e to the power of kx. Why? Because the differential of kx is k. So here the differential of minus x squared is minus 2x. So u dash is actually going to be minus 2x e to the power of minus x squared. So you write it down as it is, and then you multiply by the differential of what's inside the function. That's how you use the chain rule to differentiate. And v dash, in a similar kind of situation here, you have a function inside a function. This function differentiates how? By multiplying by the power and then taking one from the power. So you have 2 times 2x squared minus 3 to the power of 1. Then you multiply by the differential of what's inside the function, which is 4x. So you end up with v dash is equal to 8x times 2x squared minus 3. So now what we're going to do is we're going to use the product rule. We're going to multiply these two together. So we have minus 2x e to the power of minus x squared times 2x squared minus 3 all squared plus, and then you multiply these two together. So you have e to the power of minus x squared times, and you have you have these two multiplied. So I'm going to write this as, in fact, I'll do it step by step. This times 8x times 2x squared minus 3. Okay, so now we end up with this being minus 2x e to the power of minus x squared times 2x squared minus 3 squared, and that's going to be plus 8x e to the power of minus 8 and minus x squared times 2x squared minus 3. Now, most of you probably have written this the other way around. They've written this first, okay? Because most of you do this and then you do that. I like to stick to this way. Why? Because it's the same order when you do the quotient rule. And the quotient rule, the order matters because there's a minus between them. So I just like to stick to going this way and then that way. For the product rule, it really doesn't matter because you're adding them together. So the order of addition does not really make any difference, okay? Now, what we're going to do is we're going to try to now write it in the form that we need. Okay, so I'm going to, in fact, now what I'm going to do at this stage, because of that minus sign, I'm going to write this first the other way around. Okay, just because I don't want to have that minus sign sticking out. So minus x squared, 2x squared minus 3 squared. So I have to make this look like this. Okay, this is f dash of x. This is f dash of x. F dash of x. F dash of x equals. All right, so now I'm going to take out the common factors in these two terms. So from the numbers, it's 2. From the letters, it's x, so 2x. Okay, and we see we have a 2x there. Then from the e's, we have e to the power of minus x squared. And from the brackets, well, you have this is a common bracket in both of them. The one with the lower power is 2x squared minus 3. So I'm going to write that as a common factor. And then I'm going to open a bracket. So when I multiply this by this term, I have to get 8x e to the power of minus x squared, 2x squared minus 3. The only thing missing is a 4 to make that into 8. 2 times 4 is 8. The rest of it is all there. And when I multiply this by this term, what's missing? You got the minus sign, the 2 is there, the x is there, the e to the power of minus x squared is there, and one of those 2x squared minus 3 is there over here. So I have to just multiply by another one of those. 2x squared minus 3. If I multiply this by this, I'm going to get this exactly. I have negative 2x e to the power of minus x squared, and then when I multiply this out, I'm going to get that 2x minus 3 all squared. So this is factorized. This is the factorized version of what was above. And now we can expand what's in here and simplify. So this is going to be equal to, now the way they've written it, they've got the e to the power minus x squared after that. So I'm going to write it the same way that they have. So what I'll do is I'll write this as 2x times 2x squared minus 3 times e to the power of minus x squared times 4 minus 2x squared plus 3. Okay, so you'll end up with 7 minus 2x squared there. So you're going to end up with 2x squared minus 3 e to the power of minus x squared times, how do they want us to write that? A minus bx squared. Good. So it's going to be 7 minus 2x squared. So it's worked out to be exactly of the form that we needed. And we can see from this that a is equal to 7 and b is equal to negative 2. No, in fact, b is equal to 2. It says it has a minus there already. Okay, so we can say a is 7, b is 2. You don't have to actually write down the values of a and b unless they tell you to. It just says show that it's equal to this, where you should write down what the values of a and b are in the expression. You don't have to write them out of the expression. As long as you have them written down here, that's perfectly fine. So there's the answer to question 7, part B. Using the product rule to differentiate this expression. It looks a bit complicated, but we should understand how to, manipulate these algebraically, how to factorize these type of terms. Remember, the highest common factor is, for one thing, a bracket can be common, as you can see here, and the highest common factor of these power type of things is when you have the one with a lower power. That's the one that's the highest common factor. That's something we need to remember. Okay, so there's the answer to question 7, part B. And now for part C. Okay, so we have the two functions, the original curve, the gradient function with the answer there, with the values put in that we found. Then it says, given that the line y equals k, where k is a constant and k is greater than 0, intersects the curve at exactly 2 distinct points, find the exact range of values of k. All right, so y equals k is a horizontal line. It's a line that will look like this. Let me just change that a bit. So y equals k is a horizontal line. All right. Now, that line is, it says, show that the line y equals k. So if y equals k is up here, it won't hit the curve anywhere. If y equals k is down here, it won't hit the curve anyway. It can't be down here anyway because it says k is greater than 0. So it's going to be positive. So y equals k, this horizontal line, when it hits the curve at this point, remember this point was 9. Okay, then there will be not 2 distinct points. There will be 1 repeated point. So that won't be, that won't be a value of k. So k equals 9 is not one of the answers. But when k is less than 9, you can see it cuts it in 2 distinct places. So we know that k must be less than 9. K must be less than 9. Okay, however, there's a limit to the value of k, because if we draw the line here, up to here it's fine. If we continue until this point here, it's going to cut it in 1, 2, 3, 4 places. Okay, 4 places, and these will cause this not to be true. All right, it has to be exactly 2 distinct points. So it has to be above this value. We've got to find the value of this point or this point, either one of them. If we find the y value of that point, which we've got to find here, that's going to be the lower limit. So we've got to find what that point is, the y coordinate of this turning point. This is a turning point, as you can see. So how do we find the turning points? Oh, well, we already found, okay, the gradient function. And when the gradient function is equal to 0, okay, f dash of x is equal to 0, we're going to find the turning points. However, we have 1, 2, 3, 4, 5 turning points here. Right, so we've got to figure out which ones of those are going to be, which turning points are going to give these 2. When I find that, I can find the y value of the turning point, and then I can answer the question. All right, so now let's have a look. Let's get this. We got f of x equals 2x. So f dash of x, as we said, f dash of x is equal to 2x times e to the power of minus x squared. Okay, in fact, they said 2x squared minus 3. Let me do it the same way they wrote it. 2x squared minus 3. So 2x times 2x squared minus 3. Okay, times e to the power of minus kx squared, e to the power of minus x squared times, and the last bracket was 7 minus 2x squared. 7 minus 2x squared. That's f dash of x. So we know the turning point is when this is equal to 0. So you have 2x times 2x squared minus 3 times e to the power of minus x squared times 7 minus 2x squared is equal to 0, right? So those will give us all the turning points. Now, of course, you have 2x equals 0, x equals 0. That's the turning point. When x equals 0, y equals 9. That's the maximum point there. We can see that. Then we have 2x squared minus 3 is equal to 0, in which case you're going to have 2x squared equals 3. So x squared is equal to the square root of 3 over 2, which we can, so x is equal to, sorry, plus or minus, x is equal to plus or minus the square root of 3 over 2. We can simplify this, so you have plus or minus. Now this is going to be root 3 over root 2 multiplied by root 2 multiplied by root 2. It's going to be plus or minus root 6 over 2. Okay, so there's the two coordinates of, so it could, these two turning points that we just found could either be these two or those two. What we're interested in is these two. So how do I make sure which, if it's the right one? Well, we can go to the other solution, which is 7 minus 2x squared is equal to 0. Of course, e to the power of minus x squared is equal to 0. There's no solution to that part. So this one will have no solution. If you try to solve this, you'll get no solution because this curve never touches the x-axis. It never touches, it never equals 0. But this one, again, we can solve this. We have 7 equals 2x squared. So 7 over 2 equals x squared. So in a similar way, this is going to be x equals plus or minus the square root of 7 over 2. So again, we can do the same thing. It will be root 7 times root 2 over 2. So it's going to be root 14 over 2. Root 14 over 2 plus or minus. Now, how do you know which is which? Well, we could, if we wanted to, find the second differential and then substitute these values in, but that's going to be a lot of hassle. We can see very clearly that this is a turning point and this is another turning point. I know the coordinates of those turning points could either be plus or minus, plus root 6 over 2, and this could be plus root 14 over 2. Which is bigger? Well, root 14 over 2 is bigger than root 6 over 2, of course. So this must be the one that's root 14 over 2, and this must be root 6 over 2. And this must be minus root 6 over 2, and this must be minus root 14 over 2. So we can deduce by the magnitude of the, the answers here that this must be one that's further away from the origin in both cases. So that must be the one that we're looking for. So what we need to know the y value at that point, okay? So we can say when x equals, choose one of them because they're symmetrical, they're at the same level. I can choose one of them, find the y coordinate of one, it will be the y coordinate of the other. So I say when x equals root 14 over 2, then y equals, we get back our y equation. I'm just going to bring it down here so I don't mess up. Okay, so there's our y equation. So we're going to replace the x with root 14 over 2. So you have e to the power of minus, and you're going to have root 14 over 2 squared times 2 times root 14 over 2 all squared minus 3, and then that's squared. So let's see what that gives us. It says exact, so we'll leave it in terms of e. So when you square this, you're going to have e to the power of minus. That's going to be the square of root 14 is 14. The square of 2 is 4. So that's minus 14 over 4 times, and you're going to have 2 times, that's going to be 14 over 4. 2 times 14 over 4 minus 3 squared. So let's see, this is e to the power of minus 7 over 2 times, this cancels with this. That gives you 14 over 2, which is 7. 7 minus 3, which is 4. That's going to be 4 squared. So you end up with, therefore, y is equal to 16e to the power of negative 7 over 2. That's the exact value of y. So now we know that this is the y value that we're looking for, such that above that, there will be two distinct solutions until we reach just before 9. So we can say that our range of values for k are less than 9 and greater than 16e to the power of negative 7 over 2. And there's the answer to that question. That concludes this question. Question number 7 from the October 2023 International A-Level Edexcel paper. Other questions from this particular paper, you will find them in the playlist that will appear at the end of the video over here. Other questions from this topic which I guess is to do with differentiation using the chain rule, okay, and turning points, stationary points, and so on. You can find that in the differentiation playlist for P3 over here. Subscribe to my channel by clicking on this link, and you can find my PDF index documents by watching this video, which will help you to navigate through my channel very easily. Thank you for watching, and see you soon.